Okay, so first I have to say that I only succeeded at breaking a leg once, and we had to call the ambulance for the first time. But don't be scared to ask questions. Okay, so first, who is a developer? Okay, great. So, and who has experience with 3D version 1? Okay, and version 2? So why did you come here? Okay, so I have to admit I have almost no experience with version 1. But I don't know, maybe it will give you a fresh perspective on the things. So let's start. So yeah, I'm a software architect, but in reality I'm more like a developer. So let's start by looking at the regular payments you do at the shop. So you have a card from an issuer bank, and then you physically go to a shop. You show up in person. So it's called like cardholder is present. Then you typically show your physical card, which also like has to be present, card present. And then you have some way of how to authenticate you. So it might be a signature, it might be your document, it most likely is your secret PIN number, and so on. And then you enter that, let's say, PIN on a device that encrypts that PIN and sends it over a secure connection to acquirer, then up to the network, which is typically Visa, MasterCard, and then finally it gets to the issuer, where issuer approves your payment. So this is how it works in real life. Now, if we look at the dark ages of the internet, when we first, when the first payments with a card on the internet appeared, it happened almost in the same way, except that you didn't have to physically show up to the shop. You didn't have to present a card. So, and it was like a simple process, but at the same time it was a honeypot for fraud. And yes, so since there was no way to authenticate the cardholder, it was a source of fraud. And in like around 1999, for some sites it was even sufficient to have some credit card number generator with the main purpose to like get a legal like existing BIN number and to generate some random numbers and ensure that the last digit is correct according to the algorithm. And then you could succeed in, at least for a while, by paying with a card like that. Like a friend told me so. Okay, so of course over the time the situation got much better, and now the internet shops like send authorization message online, and they get a feedback from issuer if that card even exists, and there's also some fraud checks and so. But anyway, there's not enough means of authentication, so something called 3D secure was invented, and now we know this as a version 1. A couple of new pieces of software were introduced. So most importantly, there was something on a web shop site. There was something in between, and then something at the issuer. And the main principle was that using this kind of new channel, we somehow got a proof, some value from the issuer side, and then we presented the same value when we perform authorization, so that issuer can verify that it's really the same transaction. So, and what is 3D secure? It's not related to 3 dimensions. It's about three domains. So it's acquirer domain, and the MPI stands for merchant plugin. There's interoperability domain with directory server, and there's the issuer domain with the access control server. And if you look at the picture, then these new pieces of software introduced, they somehow repeat existing card infrastructure. So at the acquirer side, there's something for the merchant. For Visa MasterCard, there's something called the directory server, and the issuer has an alternative system called access control server. And why is that? Because as we heard in previous presentations, that the protocol that acquirer talks to the issuer is based on ISO 8583, which is really, really old. It dates back to the past century, and there's no way how you can add a lot of information and transfer that to the issuer. So instead of that, a new protocol was invented that produced only a single value, and of course they found a place for this new value in the existing protocol. It was much, much easier. And then I won't discuss this version in much details, so let's jump to the version 2. Visually what it does, it introduces a couple of new pieces of software. One of them is 3DS client that is closer to the cardholder. Then there's 3DS requester and 3DS server. But the basic message flow looks exactly the same in the version 1. So what are those pieces? So this 3DS client is typically just a browser the cardholder is using, or a mobile app, which is something new for the version 2. The 3DS requester is just a fancy name for the web shop or web server. And the 3DS server is the actual piece of software that communicates over this new 3DS version 2 protocol. So as we see, it didn't change much in the message flow. So what are the real changes besides those few more bubbles? So from a cardholder perspective, there are only a few visible changes. One of them is that now the whole payment and checkout process can be frictionless, and cardholder will not be asked to present any authentication value. And I think the same, at least in theory, can be achieved with version 1. But the difference is that version 2 has this frictionless feature built in, and it can skip a couple of messages that are not needed for this frictionless case. And second biggest difference for the cardholders is that it's now possible to integrate with a mobile application. So not just a web page, that is shown within the mobile application, but it can really show a native UI elements like native text boxes and native buttons. So that's from cardholder perspective. From merchant perspective, and I'm going here with a bare minimum that is needed to implement version 2. First, so here I have to say that there is no specification how the internet shop has to interact with merchant plugin. So this API between those components is proprietary, and there are many variations of that. So, and depending on how this API is built, there might be a need to implement an extra step in the payment processing flow. So for our existing customers, I know for sure that this extra step is needed. There might be other implementations of 3D version 1 that are more advanced and more future-proof. I don't know. So the other difference is that there are more fields in the message, and some of these fields are mandatory. Most likely it's a browser user agent, browser screen resolution, is JavaScript enabled, and so on. So there are a couple of fields merchants have to fill in for transaction to succeed. And another change is that version 2 had this, version 1 had this single identifier called XID. And now instead of it, version 2 has 4 different identifiers. The main important thing is that they are slightly longer. That means that in order to, so if you build your database strictly with the exact length of these identifiers, you will have to change something. And then there are different things that changed, but well, depending on how the 3DS is implemented in the web shop, those may or may not be visible to the customers. So one of the major changes is that the XML message format has been replaced with JSON messages. And in my opinion, those JSON messages also have nicer name fields. But somehow the authors of specification still preferred like these short cryptic message types. So and try to pronounce those like RREQ, RRES, and so so they saved some characters there for some unknown reason. And underneath of that is there are even more fields that merchant can provide to the issuer. So to better understand what kind of transaction it is. So just an example, there is billing and shipping address. There are some fields for prior information about authentication. And then in case it's a recurring payment, you can send a special flag that this is really a recurring payment. It will happen every month and so on. So that gives more information for the issuer, and the issuer can make decisions about frictionless or challenge flow. And another feature is that it's possible to perform non-payment authentication. It means that the amount field is not mandatory in the messages, and you can use this new protocol just to authenticate user without any financial information. So another big change in version 2 is so this is actually outside of the payment flow. This is like housekeeping information. So in order for 3DS server to understand to which directory server to send this transaction, something called like bin table or card range data is used. So based on the card prefix, it chooses the correct directory server. Is it Visa, MasterCard, or miraccept? And so in version 2, in version 1 you had to manually enter those card ranges, and you had to manage them by hand. So in version 2, there's a special message that you have to send to the directory server at least once every 24 hours, but not more than once every hour. And it returns you the whole bin table that is available in the directory server. And you also get a bookmark so you can get updates since the last snapshot you received. So this is something that happens in the background. And I think it's also a ticking time bomb, because it takes just one mistake on Visa MasterCard side, and it will update your card range tables, and suddenly all the card transactions will be routed to a different destination. So I'm not sure how this will be solved, but at least we have to watch out what's happening there and how many changes are coming from the Visa and MasterCard directory servers. So another major change is that there's an extra step within browser authentication flow, and that is every card range can have a method URL. And how it's used, so if the card falls within this card range, then before performing authentication request, the the browser must be sent to this URL, and typically the issuer will gather some information about the browser there, and then send a notification back that it has completed this process. And so why this is useful? Because it provides more information for the issuer, and he can make a better decision about frictionless or challenge flow. And one of the issues with it is that this request contains only this 3DS server transaction ID. So it's a transaction identifier on the acquirer side. So for issuer to match this with a real transaction, it has to use this server transaction ID instead of issuer assigned ACS transaction ID. So, and now I want to show you this 3DS version 2 browser flow. Partly because it's the most common, we still use browsers more than the apps. And second, because it shows most apps than application flow. So how it starts? So let's 3DS client in this case is a browser. It sends some typically some I will say proprietary, but whatever the web shop invented API request to the web shop. That is the 3DS requester. And then this 3DS requester looks up card range data in the 3DS server and replies with a 3DS method URL, if there is any. It also may, this card range data also contains if the version 1 is supported for the card or is also version 2 supported for the card. So here it's possible to switch between using version 1 and version 2. So let's say that there is this method URL and it's version 2. So then the client browser is forwarded to the URL provided by access control server, and it starts to gather information about the browser, typically by using some JavaScripts and calculating some fingerprints of the device. And then when it's done, it forwards the browser back. And now is the time when something similar to version 1 happens, where again the browser sends some web shop API call to the web shop. It creates authentication request message and sends it to directory server. It is sent to the access control server. It performs some rule checks and some scoring to decide if the challenge flow if it will present a challenge to the user or will it be frictionless. Let's assume that it decides that it will be a challenge flow. So it replies back to the directory server. It gets back to the 3DS server. And now some kind of like URL of the ACS server is provided back to the client. Client goes to this ACS, sends actually something called like a challenge request message, and receives back the challenge. The cardholder fills in the answer to the challenge and sends the challenge to the ACS again. If everything is okay, then ACS sends something called result request to the directory server, which is sent to 3DS server. Then the response is returned to the ACS, and ACS completes the flow. Once again, the message is sent to the web shop, and now web shop has all the information to send the real authorization message to the acquirer and over the network to the issuer. So, and now when I show these arrows, it's usually a bit complicated for me because I have to think about the physical messages going through the system and the browser going through different web pages. And so what's happening under the hood of these messages? Well, actually, there's a thing called iframe, and 3DS specification tells how you can use it. And there are good and bad things about iframe, but the essence of it is that everything happens with some post requests to different URLs. And here we see the challenge request message. This is how it looks in the plain HTML. There might be some additional JavaScript features that execute the post as soon as the document is loaded and so on, but this is the main essence. And if you want to understand what is CREC, then you have to do base 64 decoding of it, and then you get the JSON message. And oh yeah, you have here the 3DS server transaction ID, ACS transaction ID, and also some information about the browser. So here the window size 5 tells how big should be this challenge window. And okay, so so I showed you the basic flow, and then kind of like about some use cases of this 3DS. It is claimed that that it's not claimed, it's that we should support strong customer authentication when using 3DS Secure, which means that we have to have at least 2 and more methods how we authenticate the user, cardholder. But here, and although the kind of like this 3DS version 2 flow supports multiple challenges, there are a couple of things that bother me. One is that after the authentication is completed, the following field is set. It's called an authentication method, and it describes what kind of authentication happened. The problem for me is that it has only a single value out of this list. So, and if you look through them, there is no strong customer authentication. So, and when you fill in this field, even if you did 2-factor or 3-factor authentication, you have to pick one. So there is no way how to provide the feedback that we did a strong customer authentication in this case. So yeah, that's kind of like. And why this is needed? Well, because so currently we are talking about version 2.1, but there's also version 2.2, and one of the main features in the version 2.2 is this something called the SCA exemptions, which means that the merchant can request kind of like, don't do the strong customer authentication. But in order, so the use case how I would see is that if the customer performed strong customer authentication once, the next time should be an exemption. But since there's no way how a merchant can get a feedback that strong customer authentication really happened, then I don't know. So there have to be other factors how you choose SCA. And okay, so there are multiple things that changed in this version 2.2. The most interesting, interesting cases is that there are some changes for application-based flows. For application, well, like some fields have changed because obviously this is a new area and it's evolving as people try to implement these application flows. And one thing is that application flow in version 2.1 didn't support an empty input value. So there was no option that the input must be present always, and it must be longer than 0 bytes. So what happened if you didn't implement the checks in your mobile application, you could submit a message with empty input, and that message would not pass validation rules for the messages. And these message validation rules are pretty strict. I will show you that later. And so it's like a mystery issue, what's happening there in the system. But the truth is that version 2.1 didn't allow an empty input. They fixed that in version 2.2 by introducing a new field that says that there's no input received. Okay, so, and the other interesting thing with version 2.2 is that Visa and MasterCard are still using version 2.1, except those card range requests for Visa must use version 2.2, and everything else version 2.1. And so MasterCard also didn't implement version 2.2, but they decided to implement those SCA exemptions using some message extension fields in version 2.1. So we get like features of 2.2 in version 2.1. But that's, again, vendor specific, and there's some parsing of MasterCard style fields with the cryptic descriptions. So, and 3DS Secure is all about security, right? So, and for version 1, there were documents from Visa and MasterCard describing what you have to do to pass the certification. And there's one sentence like that all data when stored must use SCD-based keys for encryption. What is SCD? Basically, it's an HSM, so it's level 3 FIPS. And so, and for those who don't know what an HSM is and what it does, so if it says that you have to use HSM-based keys, it also means that you have to use HSM for encryption, because there's no way an HSM would give you back your key to do encryption in software. So, and because of that, a lot of our customers that use 3DS version 1 have HSMs, and they have to use HSMs even for things like TLS handshake. So TLS handshake is performed on HSM. I don't, honestly speaking, I've read those security requirements, and I'm not 100% confident that those requirements are really like written there word for word, but as I'm told that auditors that perform the certification actually require that. So, but for version 2, there are, as far as I know, there are no documents from Visa and MasterCard, but there is a PCI 3DS documents that describe requirements. And so the good thing is that here they explicitly state that there are only 2 keys that have to be managed on HSM, which is fine. That means that everything else can be managed in software, which means that there are like, it's easier to implement, and it's easier to implement in the cloud because you don't have to think about HSMs. But I still don't like these 2 requirements, and I've had discussions with our security people about that, and I will tell you why I don't like it. So these HSMs are required for, if we look at the ACS, for a single key. So when this key is used. So you probably won't see all the details here. So to the left there, it is browser flow, and to the right, it's an application flow. And if you squeeze your eyes, it probably looks almost the same, right? So it's the same. It's authentication response, then there's the challenge request, and it goes into loop with challenge request, challenge response, challenge request, challenge response. So in case of browser, everything happens over HTTPS, which is secured simply without HSM by using software encryption, and that's fine. But now, in case it's an application, then it's HTTPS. Then on top of it, something called JOSE. It's JSON Object Signing and Encryption, which basically means that on top of HTTPS, there's a Diffie-Hellman key exchange, and there's an extra encryption on top of HTTPS, which is also fine. But for some reason, you have to use an HSM on the ACS side to perform this key exchange. And then on the other side, on the mobile phone side, it's performed, of course, without an HSM. So it's probably something new to you, but as I worked with it, the information exchanged in those messages is exactly the same. There's no secret data. There are just enter an OTP we sent to your phone. Here's the OTP. So it's exactly the same information travels in case of web browser and in case of application, but for some reason in case of application you still have to do an extra encryption on top of HTTPS, and you have to do it using an HSM. So this is what I don't like about the new version. Now about implementation. Okay, I have to show this slide. So I work for Tieto. I have to tell, it's now called Tieto Every, and I have to tell you that Tieto consists of many divisions, departments, and departments don't talk with each other. So just because Tieto did something bad to you in another country doesn't mean that we did it. So we don't blame us. So what we do at my department is that we are retail payments and cards. We built a payment card products. We don't run those products ourselves. We sell those products to many banks and more than 30 countries, and we have more than 500 customers using our software. And yeah, so we are a software vendor, and our current system is written in C++ and Python. Then we use something called Oracle Tuxedo as a middleware. Probably you haven't heard about that. It's an old technology, but it's still used by a lot of telecom switches and so on. And then we use Oracle Database. We use some Java, but it's I couldn't say that we do like serious Java development, because Java mostly forwards the calls to a backend written in C++. And we use OpenLDAP for user authentication. So, but for this project, we decided to use Java 11, Spring Boot, Oracle Database, SQLite for tests, just to ensure that we don't do anything Oracle specific. And we also have plans for PostgreSQL and so on, but just none of the customers ask for it right now. On the front end, we use React and JavaScript, and we use Keycloak for user authentication. So, and how do mainly C++ developers jump into the Java 11? So, of course, there's some learning curve, but I wanted to show you that we view ourselves as these explorers of the new lands that come and try to find the best solution and the best way how to implement software. But probably for the others and for managers, we look like this, that we are just wasting time and not producing everything, because because there are things that that are not visible as a customer features, but they still must be done, like simple things like how do you install software, how do you version it, how you build the deliveries for customers, and so on. and how you do encryption and so on. So there's a lot of things to learn, but yeah. So finally, after spending some time on research and development, we got up to speed, and yeah. So and now I want to say thanks to us. There's another new product that's Open Banking API that is also implemented using the same technologies, and one of our developers who was working and discovering these new technologies went to implement the Open Banking APIs. So now, who knows this guy? No? Well, this is, I saw him at conferences years ago. His name is John Davies. He's probably, I don't know, like most best known achievement is that he was a chief architect of Visa Checkout. And he also works in a lot of fintech companies and builds highly scalable systems that process huge amounts of transactions. And there was a presentation of him where he talked about more like technological side, how to build systems that scale. And if you look at that, he mentioned one thing 2 times: no object relational mapping, and oh yes, no object relational mapping. So for a long time, I had this back in my mind, like you shouldn't do ORM. And we tried to do like plain JDBC at first, but later we gave up and started using JPA and Hibernate, which is like we are the bad ones, we use ORM. But with a couple exceptions. So instead of doing like designing our Java classes first and then figuring out how to map those onto tables, we do kind of like database first design. So because we are used to using C++ and we have to write all the SQL by hand, so we are pretty good at it and we are not afraid. So we designed the thinking about database operations first. Then we don't like explode the whole message JSON onto the columns. We store the JSON as a big block of text, and we just extract some key fields that are needed for the most common operations. We also use something called transaction template a lot, just to well, probably honestly because we are used to like having like precise transactions because we know what should be done right here, right now. And we did some modifying query which allows you some. So it's basically like a SQL, but it's a database independent SQL that gets translated to the native SQL. So we used some queries of that style just to make some couple of changes to the database when we exactly know which changes we need. So that's then microservices. Of course, like today, everyone builds a new system, and that system is microservice based. But again, so in a C++ world, we use this middleware, and we did something like microservices, I don't know, more than 10 years ago. And we saw some pros and cons about it. I'm not going to go into details, but the most important point is that microservices are fine if you're a company that develops your software in-house and you also operate that software in-house. If we have to package the software and deliver it to our customers, we can tell them like, you know, here's the list of 500 services. You have to scale each of them individually and you have to interconnect them. And then if you need a higher performance, just scale those 23 services and then do something else. So for us, it's easier to like stick to something like monolith, although it's not really monolith as well. We have some other ways of dividing the code and deliver something that is packaged and it's easy to start up at the customer side. And also, not a lot of our customers use Docker. Some do, but most of them are still conservative and have their own high-end servers with AIX and Solaris and so on. Okay, so we built the software, and then in order for it to be certified, we used a tool called UL, 3DS Self-Test Platform. This is a screenshot, so basically you can choose which one of 4 systems are you going to be testing. So when we had subscription to 3DS server and ACS, and there was more than 1,000 of test cases for each of those systems, and we had to pass each of them. There's 0 security tests for server 3DS, but there are some tests for ACS because it actually does some encryption using HSM, of course. So, and we had to pass all those tests, and well, we had some problems. Like the main was, in the beginning, it was a performance, because obviously that platform, the testing platform itself, was pretty young, and we had like terrible performance problems. I started the test in the morning. It didn't finish up until the evening. Then I found that there's a window around from 11 in the evening till 2 o'clock in the night when the tests run. So I did testing then. It also, the platform had, of course, we had to rely on the way how platform reports where the issues are. And sometimes I saw that our system is sending the message, but the platform is not receiving them. And then they dig into the platform and internal log files. And it turns out that they are mixing the message deserialization from JSON and the validation. So like an example, they expect the status N. If I send status A, it fails during deserialization, and their system doesn't see our messages at all. So I have to wonder, is it like network problem or what's happening there? Then there were some non-repeatable test results. It turns out that there's stateful card range data. So I told you we had to refresh the whole card range data from the server. But there were like, I had to create like virtual databases for each test case, because multiple test cases were running in parallel, and each of them assumed that this card range database is empty. So that was a bit tricky. I had to communicate with them to figure what's going on. Then, yeah, read it. So the ACS has to handle timeouts. That means like when user abandons the authentication in process. So, and we had a dedicated thread for handling timeouts, and it was sending timeout messages back to the directory server. And it turns out when I run all those 1,000 tests, something like 50 fail. Then I run those 50 failing again, like 2 or 3 fail. I run those again, and they succeed. What turns out was that the directory server couldn't accept messages at that rate. So it was replying and handling those messages slower. And they had like, let's say, message timeout is 15 seconds. But if I don't deliver the timeout message within 2 seconds, after those 15 seconds, then they assume they didn't receive anything. So, yeah, so I got the timeouts while handling timeouts. So this test tools also had like some high concurrency. They issued about 30 parallel requests to our system, so it was already like performance tested even before we completed it. And yeah, most of the tests were run using SQLite database. We later switched to the Oracle database, but even SQLite handled all that load. So sorry, I'm running out of time, but we finally got the thing certified. And after we got those approval numbers, we could start certification in Visa and MasterCard and NSPK. But after completing those EMVCo testing, like all other tests were pretty easy, because the tests just show successful transactions, show a reject, and so on. Like 40 test cases compared to more than 1,000, it's nothing. And yeah, so certification-driven development, that's a term I invented. So the idea is that do everything that is required for certification. Then you pass the tests, and then you have regression tests, and then you could add all the customer features onto the software, still performing those regression tests. And the reason is because if you focus too much on the user features, you probably don't know enough about how the system should work. So you make mistakes and you have to rework all of that. And it's also very good to have a suite of tests you can run on your system. So you get those regression tests after you finish the certification, and then you add features and see that everything works. So yeah, the only problem with this certification-driven development is whenever salespeople see that, oh yes, the product is certified, they start and go out selling the product, and it's hard to explain that it's not still ready for the customer consumption. Yeah, so road ahead. Yeah, so we have implemented it. We have running it at customer sites, and but of course there are like still, everything is evolving, and we still are thinking of new features and seeing what customers want. So that's it. Is there time for questions?
Not really.